So hi, I'm Radha Krishna and I'm from National Remote Sensing Center, ISRO. So I work on Earth observation data sets, right? So today I'll be giving you all and taking you all through a journey of what are the Earth observation data sets and how you can use this in kind of adding value to your own business lines. So recently I gave a kind of a talk, similar talk to a big US bank. And after this talk, people came to me with such innovative ideas that they have added value to multiple segments of the business of a US bank with ISRO's data. So something like that I'm also aiming for, and once you go out of this room, probably you'll also have multiple ideas. So to understand this Earth observation datasets, first thing is we need to understand what value do they add and what are the different kinds of datasets. So all of you attending Cypher, being an AI conference, are almost from AI or tech background, right? And because we are all tech people, we all understand how to deal with data processing. But your kind of data is different from our kind of data. Or probably some of you may already use drone data or satellite imagery, right? So firstly, let us come on a single term, and then we can go forward with the mathematics, because maths is a common language. Okay, next slide. I have it here. Can you show? Okay. So what we'll be covering is this. Firstly, we'll talk about some of the applications so that you can relate to what are these applications that we can actually have with Earth observation data. Then we'll talk about the data sets, where that is applicable, what are ISRO's EO satellites, and where you can get the data from, and some AI use cases. So let's start with use case segmentation. And I'm just starting with applications so that you will have an idea of what we are talking about. So I've broadly divided it into two parts. There is federal use cases and commercial use cases. And when I mean federal, it is mostly related to government use cases. So firstly, let's complete that. Climate change, we all know, it's a big part. And it is also influencing commercial use cases as well, SDGs, carbon credits. We all have to be sustainably aware of what we are doing and the products that we're building. Then we've got disasters, right? We monitor disasters. Again, that is also using satellites. And agriculture. Agriculture is a very big part in any government's program. And this is also being commercialized these days. A lot of agri-tech companies are coming up and taking these data sets forward. And defense. Defense is an obviously very, very large user of federal government use cases of EO data sets, right? So all this combined, right, it is obviously government use cases. But government, although it has a part of building this tech, most of the technology is actually built by companies like yours, right? And then we go to commercial use cases where you can use your this data set for your utility. We have commodity dynamics, which is a big part. So, estimating supply chain, estimating the risk. And there are companies that I know who are also trading based on satellite data sets. How much is the supply of, let's say, aluminum or iron, etc., based on monitoring the mines. We'll talk more about that. And then we have asset monitoring, right? So companies like NTPC, right? What they do is they have transmission lines. And this is just an example. So they have assets geographically distributed in a large area, and they have to monitor it. And investing in human resource, monitoring it physically will take a lot of money. So they use satellite data for monitoring. And we have insurance pricing. Obviously, this is also a big part. So our biggest market for satellite data outside defense will be agriculture insurance. So how do you, make the premiums for, let's say, a district or a agricultural unit based on satellite data and historical data, estimating the yield, etc. And then we have consumer insights. So I'll give you examples. Using AI, you can also profile your consumers. Who are your consumers? What is he capable of? What is his history, etc. And that is also using satellite imagery. So now, we understood what we can do with it, and let's understand what is this data set, right? So these are mostly open source data sets, and there are commercial data sets as well. As you go into high quality, high resolution, you get price data sets. But most of the analytics, you can also do it with free data sets. So when you talk about Earth observation, we are kind of observing something that is happening on Earth. And there are multiple processes, and based on business, it will be another, again, segmentation. So what sensors that we can observe this data sets with is primarily three use cases. First thing is satellites that we'll be talking about today. Second thing is aerial imagery, right? So aerial imagery, I mean UAVs and big aerial imagery coverages as well. So using that, you can get very high resolution, images. And one big use case will be mining. So if you want to, explore where are the mines, what is the kind of quantity of the mine that is there, or in real estate, you want to, monitor what is happening using drones or using aerial coverages. And then there is mapping use cases as well, like for Google Maps or Bing, right? And then this other kind of data is IoT data, where you kind of have sensors across large areas, and then you're getting the data, accumulating the data, storing it in your database, and processing it for various kind of analytics. That's an ocean buoy. It's collecting ocean, parameters, and then again it is uplinking the data to the satellite, and then we are getting the data back and processing, right? So these are different kinds of sensors through which we can get the Earth observation data. Finally, when you're, building your business dashboards to your clients or for yourself, you will kind of, accumulate all these data sets and build your own business cases or workflows out of it. So what is the advantage of satellites? Why do we use satellites when we have drones and UAVs, right? So the first thing is, whenever we speak about satellite, it's a space use case. And when I mean space, we send these objects into space so that they are orbiting around Earth, right? And why it is so special is there is a layer outside Earth where actually aerodynamics loses its influence and astrodynamics comes into picture. That means if you're launching a UAV or a flight, the lift that you can generate with wings actually goes down to 0 because the density of air is so low. There are literally 1 to 2 molecules per cubic centimeter, so that you can generate no lift. The only thing that acts there is gravity. So you have to model all these things using gravity, right? And when you are in that influence, what happens is there is no friction that you have to deal with. So the inertia that you give to a satellite continues itself, right? So if we escape this part of atmosphere, we go into something called a space where Karman line is the differentiation. It's around 80 kilometers to 100 kilometers. Now we use rockets to launch satellites because to escape this gravity and atmosphere, we need that much amount of energy to at least push the satellites into 100 kilometers. And most of the satellites are at 800 kilometers. Okay. Now, what is the advantages? For straightforward points, continuous movement with little to no fuel. So you can actually use your inertia to move like for a month or for a year with absolutely no fuel, with the initial velocity given by the rocket itself. Then we have faster movement because we are giving so much velocity to escape the gravity. We have a faster movement so that it can cover a lot of area. For polar satellites, it is 90 minutes to cover one orbit, right? So 90 minutes में वो पूरा Earth cover कर लेते हैं. Then we have solar energy, right? So what happens on Earth is solar energy gets absorbed and reflected by the atmosphere, clouds, and Earth's surface. Above the atmosphere, if you're putting a solar panel, there's a lot of radiation per square meter, right? So there's a lot of solar energy that you can take advantage of to keep your sensors in place. And then being at high altitude, you have larger field of view. So what happens is UAVs, they actually fly at a very low altitude. Even with a 60-degree field of view, you'll actually get almost the height amount of field of view. For example, if a UAV is flying at, let's say, 100 meters, the field of view that it can see is only 100 meters. But when satellites are flying, it's around 300 kilometers, so it can see around 300 kilometers area. So those are obvious advantages. And now let's go into the data sets quickly. So we have basically two kinds of satellites. There are other kinds of satellites as well, but what value you get is mostly using these satellites. So the first type of satellites are optical images, and when I say optical images, they are using wavelengths in visible spectrum, and then thermal infrared, near infrared, etc. So optical, when I say visible, when I say what we are able to see with our eyes and what you see in Google Maps, right? So Google Maps is a color image which is a composite of red, green, and blue. But there are other wavelengths as well that we cannot see with our eyes, but satellites can see. So here I have shown you an optical image, which is a RGB composite, and a thermal image. So thermal image is in the thermal infrared radiation electromagnetic spectrum, where if you observe the radiation, you can actually capture the heat or the temperature of that object. So whatever you are able to see in the white there is actually hotter, okay? And as I speak through this, you might get some ideas how you can use that. So one direct example of how people have been using is the thermal images. They are observing factories, right? And wherever the temperature is high, they are trying to correlate this temperature with respect to day. And they have seen that that particular graph of temperature with respect to day is actually correlated with the stock price of that particular commodity, whatever the factory is making, right? So, I mean, there are data science experiments that you can do to enable such kind of utility. Okay, and then there is second kind of satellites that are being used more these days. These are called radar, synthetic aperture radar satellites. So in the previous thing, what you have seen is the sunlight that is going to the earth, getting reflected and going into the camera. So you are seeing reflected sunlight. Here what is happening is the satellite itself will emit the radiation and observe the reflected radiation in radio waves or microwaves, right? So this is a concept image of NISAR, which I am a project manager for, NASA ISRO Synthetic Aperture Radar. So this is the costliest, expensive Earth observation satellite. $1.5 billion is the budget, almost the market cap of RBL Bank. That's the cost of a satellite, right? So what is the advantage of building such a huge satellite? So when I talk about optical images, it is when clouds are there, you will not be able to see what is underneath it. It is all cloud, right? So during monsoons, like if we wanted to, kind of map the floods or destruction, what happens is during monsoon, it's all rain clouds or clouds. Everything you will see white. So you cannot see anything. But with respect to radar, what it can do is it can actually penetrate through this cloud, molecules, and then it can directly go and hit and get the reflected radiation back. So on the left side, you are seeing an optical image. On the right side, you are seeing a radar image, okay? So the radar image, what it can give you is a texture. And for example, if you have a perfect reflected edge here, the radiation will come and get back reflected to satellite. So most of the artificial constructions or anything can be easily observed in the radar image. But when you see water, what happens is water is perfectly reflecting. So the radiation is coming and going in other direction. It's not going back to satellite. So that's why you're able to see it in a very black way. So during monsoons, if you actually use radar images, you can capture easily water. And there is also experiments that they can actually penetrate through trees also. So you can actually estimate vegetation. And there are experiments now, even the government is also doing with respect to paddy mapping, etc. So we'll go into more details later. And we have, so from ISRO's side, as I told you, there are two different kinds of satellites. We'll see the history, and these are not very latest, but till, let's say, 2015. So I'll just take you all through this. We have RISOSAT-2, which is a 5-meter capable satellite. So if you take an image, one dot of the image will be 5 meters, right? So if, let's say you have a car, it will be mostly 4 meters to 5 meters, right? You will see it as a dot. Then we have RISAT-1, which is a radar imaging satellite, which is a synthetic aperture radar, the second kind that I talked about. We have Cartosat-2A, 2B. The resolution of that is 1.6 meters, right? So if you have a car of 4 meters, you will see it as 4 dots, right? And then we have RISAT-2, which is an upgrade of RISAT-1. We have Cartosat-1, which is resolution of 2.5 meters. We have OceanSat-2, which is actually monitoring on a large scale, 1 kilometer pixel, but it can see a large area, okay? So it is used for ocean monitoring and atmosphere monitoring. This is the satellite that Indian government uses to generate potential fishing zone alerts, right? So it can actually observe chlorophyll in the ocean, and wherever there is chlorophyll, it is most probable that fishes will be there, okay? So they map chlorophyll and they add additional parameters to generate the potential fishing zone alerts, and they are sent to all the fishermen in the coastal regions, right? And there are private companies now who are doing that. And we have SARAL, which is an altimeter which can detect the height, right? And we have INSAT-3A, which is a geostationary satellite. It observes whole India at a single time, right? So these all satellites are at around 600 to 800 kilometers. It cannot see whole India. The swath, the image size will be around 100 kilometers, 200 kilometers. But for that, INSAT-3A, it can fully cover whole India, right? And we have Kalpana-1, Megatropics, and INSAT-3D. And 3DR series is also there, which is a little bit older series. And they are geostationary satellites, INSAT series. Now, I talked about these satellites, right? And they generate a lot of data. In fact, the place that I work at, NRSC, we have ground stations in Shadnagar, which is a place near Hyderabad. We have ground stations in Jodhpur and other places as well. And we have a ground station in Antarctica. So what we do is basically these are polar satellites. Whenever they get into the field of your ground stations, we get the data. And then we have almost petabytes of data. And with the NISAR that is coming, which is the very high resolution SAR data in 2 bands, we are gearing up for more petabytes of data, almost 15 to 20 petabytes of data. And all of this data for Indian markets is available in this site called as Bhoonidhi, okay? So this is our ISRO's EO data hub. Most of the data, according to the policy recently, is going to become free. So if you have some ideas of exploring or doing some experiments, or even if you're already into this field, you can get the data sets from here. right? So you can search by location or area of interest or events also. For example, if you're interested in, doing a Sikkim analysis, then you can, like the flood that recently happened, you can just search for the events. There'll be an event that is automatically detected. Then you can click and it will give the data sets. Now, the standard workflow is that you have to download all these data sets, do your own data science pipelines or analytics, right? So what happens is you need to have a powerful computer, then workflows in place to do all this. Now, we also developed a new portal called as Bhoonidhi Vista, which is visualization of terrestrial acquisitions. So in this particular portal, even you can open on mobile right now, what happens is the data that is collected by ISRO's ground stations comes on this portal in near real time. So today's data also, wherever it is collected, you can open on your browser and see very high resolution data sets. So this data that I'm showing is of RISOSAT-2 I talked about, 5-meter pixel. So we have all different features like swiping. So this is an example where we were showing the Indian government how the floods have affected in the Godavari basin. So you can do a swipe of previous day's acquisition, today's acquisition, you can get the insights. And there is also some kind of analytics also built into this. Once you open it, you will see you can measure the areas and changes, etc. Right? And we are, because this, so Vista is with respect to visualization, right? So what happens is, most of the users, once they come to Vista and okay, they have like, okay, now we understand the business or we understand our, let's say utility, we want to do more. We want to, acquire full USA, let's say, or full India. We want this Gujarat state for whole, right? So what they find problem in is, ordering all these data sets. They have to search, and there will be hundreds of thousands of data sets. They have to download, process, monitor, and all that is there, right? So for that, they, talk to various cloud companies, and then they build their own infrastructure. What ISRO is coming up with, and in the time scale of NISAR mission, which is going to be launched next year, in early next year, is something called as Code Lab. So it will be synonymous to Google Colab, but what will be addition to this is the Bhoonidhi portal will be directly integrated into this environment, and the infrastructure of ISRO you can use directly on your browser, okay? So what you can do with this is the compute, you can scale it horizontally, the storage, you can scale it horizontally, and you need not even download the data. So what we are building is something called as cloud optimized geotiffs. So what will happen is, so each size of whatever I have shown in the Bhoonidhi, it will be around 3 to 4 GB. One image will be 3 to 4 GB because there are lots of pixels. So what we're doing is we are tiling all those images, and then what we are doing is we can byte stream the data. For example, if you're interested in this estuary, then you can give the location, and then you can stream only the pixels around it into your RAM directly. There is no concept of storing the image. There's no concept of storing it as a file processing. You can just get those bytes, and then you can store it to a NumPy matrix and do whatever it is, right? So that is the kind of platform that is coming up. It's called as Bhoonidhi Code Lab. There is already traction internally in the government, and we'll be releasing it to public in the NISAR time scale. Now, let's go. Now you have mostly understood the two kinds of dataset, optical and microwave, and ISRO's datasets, and there are datasets from other countries as well, right? So as I told, RISOSAT-2 2A, right? There are datasets from other countries like Landsat, Sentinel, which are from NASA and Europe, and all of these datasets are Earth observation datasets which do not have very, campaigns for labeling these datasets, right? Till now, what we used to do, till a few years back, it was all computer vision. So we'll have thresholds, or we'll have, path tracking algorithms, backtracking and all that to even, detect reverse, right? There'll be graphs and nodes, etc. So with AI that is coming up and with GPUs, what has happened is there has been a great, effort in labeling these datasets, because even if you talk about normal YOLO kind of networks, the labeling is useful for private companies, so they put a lot of investment, right? So what happens for the satellite imagery is that there is no labeling effort. So, governments have to take care of this, and wherever a company is interested in, they will label only those particular data sets. So an effort has been put in labeling for these particular classes, and it is called as Big Earth Net. There are pre-trained models also, and there are data sets also if you want to train it yourself, right? And there are models that you can develop whatever you want, units and CNNs, and you can go to vision transformers these days, etc. So this is, and I will go gradually step by step. So this is an example of classification. So you give a patch to the model, let's say 2D matrix, and it will output a class. Okay, and the class will be somewhere in the database between those numbers, whatever it is, right? So here you are seeing an example of permanently irrigated land, beaches, dunes, sands, and they actually exist, right? And it is simple classification. It will give you probability, right? So what is this class and what is the probability? So Big Ethernet, you can use this today also, and there has been a good use case of this, and people have generated land use, land cover maps for full Earth. Microsoft and ISRO have done this, right? Now let's go to the next model. Okay, then we have segmentation. Now what we have seen is we have given a patch to the model, and it has given one number. What we want is we want to give a patch, let's say 2D matrix, and we want segmented 2D matrix as an output, okay? Like how UNet does. So there have been datasets there also. One example is Sen2 flood, which is Sentinel-2's dataset. What it can do is, again, Sentinel also has two satellites. Sentinel-1, which is a synthetic aperture radar satellite, which can, image through clouds also. And Sentinel-2, which is an optical satellite. There are two satellites in it, Sentinel-2A and Sentinel-2B, to, increase the frequency, right? So this data set can give you segment, this is a data set, you can use to segment it. So it can give you water, permanent water bodies, flooded water data sets. With this, just imagine what you can do. One straightforward use cases, you can generate disaster-prone areas with respect to cloud, with respect to flood, right? So if you wanted to, make your insurance premiums, right? There is a natural disaster component that you have to take into place. For example, if you are, let's say, SBI, and you're giving property insurance, right? This is something that you can take into picture in your model to give or make your insurance premiums, right? And these are examples of datasets. There are multiple datasets that have come into market today. Yeah, how to go previous slide? Yeah, okay. So Sentinel-2, it will be 10 meters in optical, and in microwave, it is around 7 to 10 meters. So, but what you have to do is, again, there's data processing pipelines in place. You have to bring both of them to a same resolution to put it into the model. So this is, again, there's GIS stuff like you have to resample and reproject it. Okay, now let's go into commodity dynamics. I want to just give you an example here. So what you're able to see on the left side, right? It's an example of a mine. And this is from a private company's CHAI. It's a company. So what they have done is they know what are the target mines they want to monitor. And this has been done in a country where they want to monitor the changes in mines. So what they have done is they have focused on a particular area, and based on the acquisitions, they have made the model to detect changes. Okay, so this is from an example where the model has automatically detected the change. Now what you can do from this is either your customer is a mining company and you can tell them the quantity of the mine that they have extracted to match the ledgers, or you can report it to government saying that it's something that is illegal is happening. There are two use cases, and there may be more. We might have to explore. And there is another company called as Core AI. What they have done is they have used the satellite imagery to measure or explore lithium mines. And they have done it in Canada also. And there is proof that they have actually detected lithium, right? So they are able to use satellite imagery to do exploration, change detection, and illegal mining, right? So this is just a use case. And on the right side also, you can see changes have been very clearly determined. Now, I was talking about asset monitoring, right? This is an example of asset monitoring at the transmission lines. So again, going into the domain, what happens is whenever a transmission line is being laid, there is a survey that is done. And after the transmission line is laid, we have to monitor it, okay? And it's like kilometers, hundreds of kilometers, the network is there. How do you monitor it? At least to get initial alerts, right? So the primary problem is two things, water and vegetation, okay? So this example is with respect to vegetation, and satellites have been used to detect vegetation, right? Satellites can do that using optical imagery. And when I say optical imagery, again, you have to imagine the primary difference is we have RGB, but we have multiple wavelengths that we can put into satellites, right? Near infrared, far wave infrared, and even in thermal also, right? So it is like a spectrometer. If you know what a spectrometer is, it can give the signatures of any particular material, right? So sunlight is getting reflected from the vegetation, and you are able to see the signature. And based on the signature, you can tell whether a vegetation is healthy, what is the life of the vegetation, life cycle of the vegetation. And adding to that, there are multiple parameters as well. For example, if you wanted to detect the height of the vegetation, right? How would you do that? So one example is if you go to Google Maps and go to some forest, you will see shadows, right? And for any satellite image, we know the time of imaging, we know where the sun is, and thereby we know how the shadow will fall, right? So from the angle, from the length of the shadow, we can say what is the height of the tree, okay? And from the height of the tree and from the vegetation health, you can say whether that vegetation will be problematic to the transmission line provider or not. And this is the same kind of philosophy that has been used in urban consumer profiling also. What is the height of a building, right? We never know what is the height of a building from satellite imagery if you just look at the imagery. But if you kind of take the time of acquisition, take the shadow length, and shadow length is easy even with computer vision, right? You can just put a threshold, it will be black, dimmer than all the surrounding pixels, you can extract the shadows. But if you want to do deep learning model, that is also available. There are YOLO models that can, extract the shadows, and they can provide you what is the shadow segment, and thereby you can, extract the height of the building. From the height of the building, there is again, you can put it into your models, get, let's say, what is the per capita income of that neighborhood, then, make your sales pipelines, whether we can go into that neighborhood or not, are we existing there or not, etc. So I'm just, diversing from a particular use case. And this is for asset monitoring. So what this company will do is, okay, the vegetation is there, the health is there, so it is a problematic, area. Let's send people to understand more, right? So that's what they do. Now, as I told, vegetation is a very big market, and biggest market right now, even with respect to private companies, space tech companies like Cypher, it's in Bangalore that is coming up, is insurance premiums, right? Government actually gives a lot, contribution to farmers in insurance premiums. If you are, kheti kar rahe ho aap, then you can contribute a little amount, and government also matches your contribution to get the premium when your crop fails because of anything, right? So how do you, make your premium pricing, right, with respect to agriculture, and there's other markets as well. So the premium pricing is made with respect to historical data that the government has, in situ data and the normal data, that okay, yahan pe ye kheti hua tha, this was the yield and this was the supply and demand, this was the price. That's one kind of data. The other kind of data that we have from 1990s is satellite data. So how do we use satellite data? Is this straightforward example. You're seeing cycles, right? This is with respect to one farm only. And the cycles that is showing is that, okay, in one season, this particular farm has given a lot of yield, and the other season, the farmer has not done anything. There is a noise amount of vegetation there, right? So this is the cycle that is there, and this is just a straightforward example. There is other kind of complicated examples as well. And when you put that through your model, what you can understand is the yield, the health, and there's other kinds of parameters for each specific crop type, right? So first thing is you have to classify which crop it is, whether it is paddy, whether it is another kind of crop like tomato or banana, etc. Once you know the crop, then you know what diseases it can get, then you know what kind of yield it can give, and from the historical data and from the satellite data from the patterns, you put it into the model, and it can give you whether this will be successful or not, and you can analyze and do your data science experiments there. And this is being like, what government is doing is it is kind of mandating satellite data use in the field, because normally how insurance premiums are calculated is with something called as crop cutting experiment. So they grow on ground and they estimate yield with respect to a sample crop, right? And this is done across India. So you can imagine what kind of, cost that it takes to, do the crop cutting experiments. Now it is mandating satellite imagery because it is a little bit cheap, and it is also, research has been done, and it is very well proven that data can give us better, profits with respect to NBFCs. Now we have consumer insights, and this is a well-known example. So this is, I think, Walmart, and they wanted to kind of do their consumer profiling, right? And again, here also there were two outputs. One thing is, this is looking at a parking lot. So this is a high resolution image of a foreign satellite provider. And what they have taken is, firstly, they have estimated the car segments, okay? There we got number of cars. Then again, they plotted number of cars with respect to day, and then they again correlated with stock price. And again, it got a good correlation. So one thing is, okay, there is some kind of demand we can predict with respect to how many customers are coming to the shops. And this is only valid when the cars are visible. The other kind of profiling that they have done is, they see, we cannot see with our eyes what that car is, but actually AI models can predict what that car is, and when they trained these data sets, they got what that car is and different kinds of how much per capita income for the particular consumer and how much not. So they got a Gaussian curve, and then they predicted, okay, so on these days people with money are coming, on these days people with money are not coming, so what we have to do, and so on and so forth. So for Walmart's analysis and for other trading companies as well, this has been proven good, right? So this is with respect to consumer insights. And again, this is just one example. There might be hundreds of innovative ideas like this that you can take from Earth observation datasets. Right. Now coming to Gen AI. So now till now what we have talked of is classification, segmentation, then we have computer vision, then we have spectral analysis, then we got object detection. Now we're coming to Gen AI, and in fact, the open thing is that Gen AI has been in use with respect to images, right? Till now, what we've heard of till morning, from morning is natural languages, LLMs, right? So Gen AI, I mean, the kind of things that happened in images was from way before. So Google has been using the satellite to map conversion, right? What is this? This is just a style GAN, right? So what happens is, or a pix-to-pix GAN also you can use. So this has been happening from a lot of days, and again there's QC and there is modification over that, but in principle this was done from way before. Now what is happening is, since the transformers have come in natural language, even image processing also took a very big step into vision transformers, right? So all the generative AI models in the images that you see, even the GPT-4 that has been released, right? You upload an image and it will give you what that image is. Again, it uses vision transformers, right? So this is an example that you can use directly to, give a context of what is there, right? I'm just giving you in the style of Google Maps, but what you can infer from this is, it has detected roads, it has detected buildings, it has detected vegetation, it has detected water. Now estimate what you can do with this kind of analysis, right? Buildings you can extract, roads you can extract, you can kind of monitor the roads, you can inform civil authorities, or you can take contracts from civil authorities. There are multiple things that you can do, right? The second kind of work that is being done by companies now is, see, there are two satellites, right? Again, two kinds of satellites, optical satellites, radar satellites. To build and launch a satellite, it takes a lot of money, right? And if it's a good satellite, it may even go into hundreds of crores. So what we can do with this, if you launch an optical satellite, there'll be always clouds, and whenever there is rains, you cannot do anything. So what people have done is, they have taken SAR imagery and then they have put it through transformers and GANs, and they have generated optical imagery out of it. So now you can have a synthetic aperture radar image, and because there is no clouds there, put it through your knowledge, training, and transformers, then get an optical image that looks like a Google map. And this has been used in production also for vegetation analysis. So here, you're literally not able to classify, it's just a grayscale image. It's like values from 0 to 1. But there we have wavelengths, like in red, this is the value, green, this is the value, blue, this is the value, infrared, this is the value. So what people are able to do is take a value from 0 to 1, add additional dimensions to it and give a particular value. Okay, this is vegetation because it has a context, right? So it has a context from surrounding pixels. It is able to tell whether it is vegetation or not, or even with respect to water or urban buildings, right? So what is the value addition that can be done is, private companies have now started to use SAR images, even in monsoon regions, to calculate agricultural premiums, right? So they are able to detect vegetation, what is the health of the vegetation, what are different patterns. Now what they are doing is, from 1990s, they are taking radar images, converting it into optical or other dimensions, and then they are kind of making these data sets for their own models. And this is with respect to Gen AI and vision transformers. I think that's it. I hope I have given you all a very comprehensive coverage of how Earth observation datasets may be, thank you. Thank you. So I hope I've given you all at least some starting thoughts in your own business lines. And I'm open to questions, and you can follow me there.